Hello and welcome to another video here on TryHackMe. Today we're going to talk about something new, interesting and exciting called the OSI model, which is a 7-layered model to explain how to find bugs on network. That's how I learned it. These days, the OSI model is used to describing the fundamentals of network. But that is also okay, you know. In the original explanation of the OSI model, it was a model used to find bugs in networks, so you can divide every single layer into something that could be, tested on a computer. So the very first text here is basically all about what is the OSI model, and we will see the 7 different layers: physical layers, link, network, transport, session, presentation, and application. There are many different, represented models that looks like this, called the TCP/IP stack model, or the internet model, or the internet stack model, or whatever name they give it, only containing, depending on which shrinked version it is, 4 or 5 layers. They all exclude presentation and session, and one of them actually also exclude the physical layer, because it is more or less just saying cable, modem, tower, it's not really network related anymore. It's when the signal is out of your computer. So yeah, that's boring. So the first question is that what's the OSI model stand for, and I'm not gonna type this. It's being here, open system interconnection models. Let's just copy paste the text and see if they do not want this. The OSI, maybe they want it without the word model. Yeah, there we go. So how many layers? 7. What is the key term? What is the key term for when piece of information get added to data? What is the key term for piece of information get added to? I don't know what they want me to, but I guess they mean encapsulation. Yeah, they did. So sometimes, the way they ask is a bit weird, but it's just gonna, get away with it. So the very top layer, some people call it the first layer, other people call it the bottom layer, because it is kind of 7, and 7 is top, but 1 is first. So yeah, it is the top layer, or the 7th layer. It's just the application layer, the app layer. Basically, the application layer is what you kind of think it is. It is the graphic user interface. It is the programs, the processes running. When you are a programmer, you probably heard about a application layer protocol, which is basically just you writing your own protocol using normal socket communications, and you can do that by just exchanging a very standard binary string or strings of strings, array of strings, basically whatever method you would like to do. So what is the name of this layer? If I want to type application on the application layer, that is quite silly. What is the technical term that is given to the name, the software that users interact with? I think they want graphical user interface. Again, I'm not going to type this, so I'm just going to put it there and say that's it. Basically, the application layer is the programs, right? It is the user applications running computer. It's nothing fancy, anything. If you dig down on it just too much, you're going to end up another layer, and that is really the point of the application layer. It is just the applications. So in the old days, by the way, when something was wrong, let's say a user called support and say, okay, my browser doesn't work, the first thing is listening to the user. What did they report? Did they say the browser doesn't work because it doesn't show any internet? Well, then of course you could start up saying, let's look at the application layer. Is the application actually working, right? Is it frozen? Is it you can probably get the point. Then you go beyond. But let's let me continue with the next layer. It's called the presentation layer, and the presentation layer of my cat jumping into a card box. All right, it's a 6-layer OSI model. basically it is where the presentation is. A little more difficult to explain, but I think I think there should be a line of text saying like this layer acts as a translator for data to and from the application. So when you present your application to the user, we just do it through like tools, like you have a button you can click, and when you click that button, you do some sort of action, and that action is being translated directly down to the code. Well, we're gonna say that. So we're gonna need to write presentation, and I know, please let me copy paste the word presentation. Oh, mamma mia. Okay, no, I'm gonna take it. There you go. What is the main purpose? What word do you want? Translator? Yeah. So basically that's what they want with this. So that is translating the session layer itself. It's good. Session. Sorry, couldn't help myself. They keep asking stupid questions, like we're reading about the session layer. What is the name of this layer? Did I read that right? Did I read that right? You know what I mean. If you watched. Yeah. Anyways. It says like once data has been correctly translated or formatted from the presentation layer, the session layer, layer 5, we're going to create a connection. So whenever you have a connection, in some way, depending on and this is going to be tricky, because you will say connection wise I'm using a TCP protocol and la la la. Yeah, you are, but this is just not that layer. So it's one layer below, but it is the actual layer that is meant to do this. So this is another layer that just connects those two other layers. So I guess, what is the technical term for when a connection is successfully established? Well, I would just say open connection. There's some hint to this. They're unique per connection. Yeah, they are, I guess. I don't know what they want to call them. Sessions, I guess. Session. There you go. The word session is something commonly known in web application development, is when you have an active session, probably also what you learn. So what is the technical term for small chunks of data? There's so many packets, I guess would be one of them. So we can also just call it small chunks of data. Alright, so transport layer is the first one that is a bit more advanced. It contains the two different protocols. The one called, let me see, have many questions? Oh wow, now the questions come. Transport, did I read that right? Sorry for that. So the first one is called TCP. It's the transmission control protocol. And the second one is called UDP, which is the user data gram protocol. Now, the all main difference between the two protocols, I guess they try and show it with the two drawings here, that you have a connection to a web server on a computer. You want to download a picture of a lovely dog, I guess. And the dog image is small enough to be, chopped into smaller packets and then sent over the network. With the TCP protocol, which is also standing for Transmission Control Protocol, it guarantees the accuracy of data, and it's it doesn't all data is being shipped. There is a guarantee of no loss of data, which is why the whole picture is always going to be there. Of course, there are some disadvantages by it requires a bit more bandwidth. The speed is less compared to UDP, which is more like you can probably call it a broadcasting or spamming connection type. And it by the way, also starts with just sending as much faster. Sending data much faster than the TCP protocol, which is And this is commonly misconceived, is that UDP is faster than TCP, and that is raw bull hair on a dog. That's not true. The data is being shipped at the same speed over the cable because it is the same speed every time. What causes the difference in the UDP and TCP protocol is that the TCP protocol got something called the slow start principle, which is basically data being sent slower, so you don't create a congestion on the cable, or it's called congestion control. So you basically do not send too much data that could not be sent at the given moment, which is a way of controlling not having too much packet loss, where UDP just like spam all of it at the same time. In most occasions, you can, with a higher speed of connection these days, get all the data, but in some other occasions, and usually it's on something easy, when a new game is being shipped, online game, and too many clients buy it, and the owners of the game didn't anticipate it, well, then it will lag and packet loss. You're gonna have rubber banding and stuff like that. Usually you can say that it's a cause of UDP. Many games also uses TCP, like World of Warcraft, but it's not really gonna change much in this occasion. Also, UDP is mainly used for streaming because it doesn't really matter if you miss one dot here and there, because it's so fast updating the screen. Sorry, they're probably gonna ask me for what UDP stands for here. Oh, who have known? So let's see. Transmission Control Protocol. There we go. TCP, guarantee the accuracy of data. What protocol doesn't care if it's UDP? We just said that. What protocol will applications? Email client, TCP. Yep. What protocol download files? TCP. Because we want all the file and all the email. Stream for video, UDP. So onwards and down to the network layer. The network layer is a little more tricky diggy. It's where we it's called the third layer of the OSI model, and it's where like the magic happens when we are routing. We're gonna look at the routing information protocol. We're gonna try and use the open shortest path first protocol, and we're gonna try and we'll basically find the fastest route from A to B, which is done at looking on the IP addresses. But it's not the whole truth, because the real actors in finding the fastest route is the routers on the network, which are these things here. I'm going to use something called a BGP protocol, Border Gateway Protocol, which is basically looking at big interconnected networks as network nodes, you can say. And this tutorial doesn't really talk about that, so network. So will packet take the most optimal route? Yes, that would be very interesting. If it, what does the yeah, man, really gonna. This is the problem with me not typing long text. It's gonna be like whoosh. So let's type this. What type of address is dealt with IP addresses? So let me just, I'm the master of copy paste. So there we go. That is the questions. If you read the text, you will get to the same point. All information is always there. Get to the data link layer, which is another tricky diggy layer. Tricky diggy. It is also known as the MAC or the LLC, I think it's called, but that is not really here. So let me just type this data link. You should not stop asking these questions. So this is where the data actually looks at the link of it, which is why it's called data link, and you can look at something called the MAC address, media access control. And when the data is already being transferred from the router going back to the network layer here, it is never hitting a computer directly. There's always some sort of mechanism like a switch or something between, maybe not in your home network because you're directly hooked to some magical unit called a AP or Wi-Fi AP, and that AP can do many things, so it kind of also acts as a router for you because you are directly hooked to it with an IP address delivered from that using something called the DHCP, Dynamic Host Configuration Protocol, which is also not a part of this easy small tutorial, but look it up. It's not that difficult. I'm gonna do network videos in the future on my channel, so a lot more in depth than this. This is just a room on TryHackMe to get you started, so I'm not really gonna make it advanced. So you're gonna look at the data link layer. So whenever the packages have been shipped from the routers, and I'm gonna hit a switch, sorry, then the switch will look at the data link. So switches are usually normal switch at least, and this is where there are different switches, but anyways, let's stick to this part. Gonna look at the MAC address and ship the packet to that particular computer, but that MAC address that is connected directly to the network interface card, also called the NIC. And I guess that's also the answer for the last question. Just put it there. Okay, so when I get to the last layer and the most interesting layer of all, we get into rubber and iron and copper. So that is the easiest layer to grasp, as they tell us. What is the name of the layer? Oh, frick. Let me just put it there. What is the name of the numbering system that is both 0 and binary? What is the name of the cable? Oh, mamma mia. I'm just gonna start spell the cat category 5. What's it called? Let me see. Are not telling me? What is the name of the cables that is used to connect devices? Did they give me a name? Really? They didn't want me to write physical components? No, they did not want me to write that. Interesting. Did I not do as put simply layer reference physical hardware used devices, electric signals to transfer data between, example, Ethernet key. Oh yeah, okay, of course. So many years ago, Ethernet this and that, and that is actually a protocol, but let me just leave it there. So now we're gonna go to the OSI game. Oh, wow, okay, let's see. We're gonna find a flag, so I hope you're familiar with that. Insert card play. What am I gonna do? Oh. Whoop. Oh yeah. Oh. Well, I'm not really sure that. Oh, they want me to pick the. I didn't read it at all. Like physical data link, network, transport, session, presentation, yeah, and application. That's the right order. So we're gonna get a flag now. OSI Dungeon Escape. Wow, really good. So let's close this window. Alright, so continue learning. Let's just complete this room here. The one so I continue learning packets and frames room. Can I click it? And I kind of suggest that you, yeah, I think this is a really good room. It looks like it's a really good room, so I suggest you go ahead and continue on with this room here called packets and frames. And I just really hope you learned something watching my video, and that is the whole point of me recording those. I'm just gonna say until next time, have a really good time, watch more of my videos, subscribe to my channel if you wish to, leave a comment below, and return back to you. So, bye.